So I want to just take a few minutes and talk about each of these characteristics because animal evolution is just fascinating with some of these major feats in evolution that we've accomplished that have allowed us to branch out into other ecosystems on this earth. So if you look at multicellularity, you can see that it pops up way down here at the beginning. So right after archaea, we've got sponges on up that are multicellular. And one of the main advantages of multicellularity is that you can specialize, right? So not all my cells all have to do all of the things that I need them to do to stay alive. So I don't have to have a cell that's doing digestion but also electrical impulses so that my heart will beat, and also exchanging oxygen so that I can have oxygen in my cells to metabolize my food. You can specialize into different compartments so that each cell has its own little function. Disadvantage, though, is that, well, first of all, one of the main things that cells have, and organisms in general, is a way to fight off competition or an incompatibility with others, right? So sort of an immune system. And so if you're going to take a bunch of cells that are normally competing with one another, and you're going to bring them together into a multicellular organism and force them to be symbiotic, to work with each other, there's got to be a way to overcome that incompatibility that we have as you bring these cells together. The other issue is that, and this is in humans, right? We see this all the time, that because the cells begin to specialize, they turn off parts of their DNA, so they're no longer a stem cell, right? They're a differentiated cell that only does one function. And so if you kill off cells in your body, you can't just replace them with any old cell. It has to be a specialized cell. So there's some challenges with that as well. The nucleus also evolves at that same location, and really all the nucleus is a membrane that's going to encase the DNA, sort of protect the DNA. So it's no longer just sort of free floating through the cell like it is in a bacterium. It's now protected, and so you can see the obvious advantage of having your DNA protected. But some of the challenges are, now if you want to copy that DNA and you want to split the cell, do binary fission, or what we call mitosis, you now have that DNA in this tiny little compact space. And so we've had to evolve mechanisms for the DNA, or for the nuclear membrane, to break down before mitosis takes place. Looking at, what's another one? Bilateral symmetry. So if we go here, bilateral symmetry evolves right here. So the first ones to have bilateral symmetry are flatworms. And one of the things about having a right and a left, a front and a back, is that you can specialize your sense organs. So think about, your ears are on a left and a right, your eyes are on the front rather than the back. And it allows you to be better at using your sense organs, but there's some challenges, right? Because it limits what you can do in any given direction. So if you're a cnidarian, like a starfish or a sea anemone, and you can go, well, I guess a starfish doesn't belong in that category. Anyway, you can go in any direction, right? All of your different directions are the same. Whereas if you've now got a front and a back, well, I can only go in one direction. I can only bend in one direction. And one of the interesting things is the sense organs. If you look at like predator versus prey, so think of a cheetah versus a gazelle. And if you'll notice, the sense organs in a gazelle, the eyes, are actually towards the sides on the right and the left, which allows them a bigger view of what's around them. It's almost like having eyes on the back of your head, right? Whereas humans are more like a predator, where our eyes are in the front, which allows us depth perception. So we're much better at catching prey that are moving really fast. So there's advantages to both, but having those sides means I don't have sense organs on the back of me. They can help me sense when a predator is sneaking up on me. So there's challenges there as well. Jointed appendages. So if we look at jointed appendages, I'm not sure I actually have that one on here. But we're getting jointed appendages with our insects have those jointed appendages, crustaceans have jointed appendages. And so when you have these joints, obviously that allows for much more complex locomotion. So all the way up here we've got jointed appendages as well. And that allows us to move better. But at the same time, think about your joints and how delicate they are and how much injury we sustain at joints. So joints, we've had to reinforce them with tendons and ligaments and cartilage and fluid in those synovial compartments to help us move them better. But they wear out, right? I mean, if you've ever seen somebody who's older and has got arthritis, these appendages, the joints, wear out. So there's challenges to that as well. A vertebral column, or a backbone. Okay, this is a very big innovation, and you can see it's right here, right? So the first ones to have that are chondrichthyes, or our sharks and rays. And one of the major advantages to having a backbone is it protects your dorsal nerve cord, your spinal cord, right? That's a very delicate piece of your body that if it gets injured, we all know what happens. It can be devastating or life-threatening. And so to have a bone that encases it gives us a huge advantage, especially as we move on to land and have to deal with some of the harsher environments that we have here on land where gravity's having an effect. And so that's a good thing. But some of the challenges of your spinal cord or your spinal column is that, have you ever known anyone who's broken the spinal column? If you break the spinal column, it can cause massive damage to the nerve cord underneath. In fact, that's usually what is the case of paralysis. So for instance, I have a cousin who broke his neck, and he was at C6. He dove into some waves, and the waves broke, and he dove into the sand, and he broke the C6, and the bone is what broke. The spinal cord was actually fine, but all the swelling from breaking the bone actually destroyed the spinal cord. And so a lot of times the treatment now is, if we can get to you soon enough, we can try to prevent that swelling and the damage of the spinal cord. But that's one of the challenges of having that giant bony vertebral column. And then think about all the people that have back pain, right? Again, it's a joint that we've got to maintain. Tetrapody, so having 4 limbs, and you can see tetrapody is right here where we start climbing onto land. So obviously that's the huge advantage, right? You can climb up onto land, you can move, you can walk. But one of the challenges is, once you climb up onto land, you have these 4 appendages. How do you support the weight of your body? And so you'll notice, like, look at a crocodile, for instance. They kind of walk with their legs out like this and shimmy their belly along the ground because they're so heavy, and having these 4 appendages the way that they are is not super conducive to walking upright like a cow, for instance. And so it requires a lot of manipulation and evolution of the joints in order to walk with our limbs beneath us. But there's all kinds of problems, right? We have back problems, and we have joint problems from having these 4 limbs. Amniota. So this is an amniotic egg. This is an egg that has that hard shell and the liquid inside. One of the huge advantages to this is that we can now leave the water, right? So you don't have to be dependent upon water for reproduction, because your eggs have this hard shell that can protect them outside the water. So you just see this in your reptiles and beyond, where they can lay on land their eggs. And that is a huge advantage, but now we've got to figure out how the baby gets out. When we're talking about little fish eggs, they just kind of poke their little nose and they're out. It's a soft shell. Whereas if you're looking at a bird, they got to peck their way out of there. And if they can't do that, they don't make it. But we've even evolved so much that some organisms require that struggle in order to increase their survivability. So there's challenges there as well. A placenta. So live birth. So you're seeing that only in the placental mammals, which actually gives us a huge advantage. In fact, if you look at Australia, in Australia, marsupials evolved. So that's where their offspring are born way premature and climb up into the pouch and have to mature there. It's not as, and monotremes, same thing, that lay the eggs. It's not as good of a process as placental birth. But because mammals weren't introduced into Australia until much later, marsupials thrived, right? But if mammals had evolved at the same time, they would have outstripped the marsupials. And that's why you don't see marsupials in places where mammals are, because the placenta is a really great advantage, because it allows you to keep that embryo inside of you until it's ready to stand up and walk on its own. If you've ever seen a cow be born, it just stands up and moves around. Humans are sort of moving back towards marsupialism, where we're born super premature. But that's because our heads are so dang big. So that's a great advantage, but one of the disadvantages of placental birth, to have a live birth, is that you've got to carry that baby with you the whole time you're pregnant, or the whole time it's growing. Like, think about a crocodile, right? They lay their eggs and they might protect their nest, but they don't have to do much else, and they can get away from predators. Whereas if you look at a human, we get huge and fat and clumsy and slow. So a lot of animals suffer predation when they're pregnant because they're so slow, because they're carrying this giant baby with them. Not to mention the fact that you're constantly feeding it from your own food supply. It's almost like a parasite. I love my children, but I kind of think of them as parasites. Anyway, so that's the disadvantage of having a live birth. But we can see, based on how much mammals have taken over, that it really does. The advantages outweigh the disadvantages. So those are just my thoughts on some of these really cool features that we have evolved as animals have progressed.